Okay, this page is about scientific notation with positive exponents. This is page 10. Now, I made you a copy of my notes for this page so you wouldn't have to copy all this, but I'm going to write it in here and I want to talk with you as I do it. Scientific notation is not on the practice test for HESI, but I have seen lists of HESI skills that tells me that it is on there. So I didn't want to just skip it. I wanted to make sure that I gave you the skills that you may need. But I'm going to let you decide whether or not you want to study this. I just want to present the info to you and let you decide. Okay, so scientific notation allows us to write very large, those are numbers with positive exponents, or very small, these are going to be numbers with negative exponents, and that'll be covered on the next page. When I say very large, I mean very large, like light years large. If you take advanced sciences, you will be able to do math much quicker by using scientific notation. By using significant digits, and that means digits that are not zeros, and powers of 10. And I'm just going to show you this just like I would in the classroom. If we were doing this in our interactive notebooks in the classroom, I would give you some little post-it notes. So let me bring in a couple of those. I'm going to use just small ones that will fit in these spaces. And I'm doing that because these are the only numbers that we can manipulate. The times 10 is part of the formula. We can't do anything with that. It's not movable. But these post-it note numbers are movable. So on the pink one, I'm going to use, let me just use a whole number, an integer for this start one. Let's use a 5 here. It could be anything from 1 to 9, a whole number. And for my exponent, I'm going to use, actually, I need to stick with what I did in the notes, don't I? Okay, let me just do it this way then. In the notes, I did a 1 in this slot, and I did an exponent of 13. Now remember, these are the only things I can manipulate. Those post-it notes I can move. The other part I cannot. So here's what it would be in scientific notation. And this is very similar to what I wrote in my notes. Since you have a copy of my notes, I can't really change things up. But scientific form is 1 times 10 to the 13th power. Standard form looks like this. I write down the leader and any non-zero numbers, and in this case our leader is a 1. That's the pink number. Then I'm going to draw 13 blanks. Bear with me here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? And I'm getting that from the yellow number, the positive exponent. Remember, these are very large numbers. And then I'm going to fill those spaces with placeholders. You can use zeros, and that's all. Don't put any other number in there or you have changed the value of your number. So every 3 places, I'm going to put a comma. If I could see the decimal, it would be over there at the end. and we're bringing in every 3 slots a comma. And then you can read the number. This is the units section. This is the thousands section. This is million. The next one is billion. And this next one is trillion. I think the national debt is more than this amount. It is so big. So word form would be 10 trillion. Okay. Let's try the next one. Here's the problem. It says to convert. Well, I didn't give you that one, did I? Let me go ahead and write it in. You can write it in here too. Convert 68, not thousand, million to scientific notation. So we're going the other way this time. All right, so we have 68 million. Let's write that down. And we're going to just undo what we did. So we did 1, 2, 3, 4, 5, 6, 7. We did not underline the leader up here. Remember that pink number just comes down. The 13 is found in these numbers. So we're going to do the same thing. These go with the exponent. That leader goes here. Okay. So the leader is 6. You can only have one digit in the leader slot. It can be a 1 to a 9, but no more. That 8 is not a 0, so I can't just let it be consumed in the exponent. It's not a 0. It's more than just a placeholder. So we're going to go ahead and write it down here. It just can't be with the leader. It has to be the leader, a decimal, and then anything else you need to add. Then 10, that's built in, times this number of places. And there are 7 of them. So that is your exponent. 6.8 times 10 to the 7th. And this is the scientific form. This is the standard form. And I guess I just didn't finish the word scientific. Okay, let's do another one or two. We'll add maybe another example. I really wrote this one out in longhand, didn't I? But okay, convert or change 16,503,000 to scientific notation. And I wrote out the steps for you. I won't do that in this video because that will just put you through a lot of time that you don't need to do. But the first step is to write down the leader digit. So let me bring this over so we can see it. This is standard form. Did I get them all? Yes. Okay. The leader is what? Can only be the first digit. So the leader is a 1. You write it down. If all you have are zeros after that, you don't have to worry about a decimal. But we have other stuff. So put the decimal. We have 6, 5. I have to write this 0 to get to that 3. I can't just skip it. It has to be included to push the 3 out where it needs to go. So you've got the leader and then the important stuff times 10 to the 1, 2, 3, 4, 5, 6, 7 places. So that's to the 7th power. This is scientific. And this is standard. And I have room here. I'm going to squeeze in another example that is not in my notes. I actually have room for a couple more. So you can squeeze this in here. You could also write on the back of page 10. Let's do this number. Let's do 3.08 times 10 to the 9th power. So that is scientific. I want us to find standard. So let me bring it over here. I like to work right underneath it. All right, so I'm going to write down my leader and 9 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Leader, and then 9 blanks out through there. Okay, we have to include the 08. Once you get that in there, then you just round out those spaces with zeros. Put your commas in. And you end up with units, thousands, millions, billions. So this is 3 billion with a B. Then there's a comma. 80 in the millions section. And then zeros the rest of the way. So 3 billion, 80 million. All right, here's one more. Let's do 1.3 times 10 to the 5th. So we write it down, or I do, just because it helps me line everything up. I bring the leader down. Leader doesn't get a blank. And then I add 5 spaces. So here's the anchor, that one, and then that yellow one. And here comes the 3. It has to sit right after the leader, and then we round out the spaces with zeros. So we have the unit section and the thousand section this time. We have 130,000. So there we have scientific, standard, and word form.